Okay, welcome back to my YouTube channel. It's me again, Webster Chileshe, your tutor in mathematics and sciences. So I've come with you today with physics. We want to revise this question from the year 2020. Okay, so I want to see how to solve this question. The topic where this question is coming from is work energy and power. Work energy and power. Okay. But before we get to into details, please don't forget to like the video, share, and most importantly, subscribe, become a member, and hit that red button as well as the bell for you to be notified as soon as possible whenever I post a video. Okay, now let's get into business. Now, physics is one of the simplest sciences because it involves too much calculations. Of course, calculations are quite easy for everyone, despite as long as you know the formulas. Okay, figure 1.1 shows figure 1.1 below is the diagram showing a stone of mass 2 kg. So it has the mass of 2 kg that was pushed up the slope from Q to R. So from Q going way up to R. So this is the stone which was pushed from Q up to where R is. Okay. Now this is the diagram. As you can see it, we have this point T, we have the point S, which is the midpoint. That is the midpoint, the R and the Q, and this is the ground there. Okay. Now the first question is, the statement is 72 joules of work was done in moving a stone, the stone up the slope from Q to R. So 72 joules of work was done to move the stone from here up to there. Okay. The question is, what is the potential energy of the stone at R? What is the potential energy of the stone at R? Okay, you may be quick in thinking of the formula for potential energy, which is potential energy is equals to mass times gravity times the height. But in this question, there is no need of you applying that formula. The only concept you need to know is that the work done against the object is equal to the energy possessed by that object, either potential energy or kinetic energy. Okay, so in this case, we have been told that 72 joules of work was done to move this stone from here to there, which simply means that even the potential energy possessed by this object or by this stone is the same 72. So question A, the answer is 72 joules of energy. Okay, let me say potential energy is equals to the work done. Potential energy is equals to the work done. The work done was 72 joules, which makes it potential energy is equals to 72 joules as well. Okay. So the potential energy in this case is 72. Okay, we move to the next question. B. If the stone falls through side RT, what would be its potential energy? What would its potential energy be at S, the midpoint of each fall? So if this stone had fallen this side, which is RT, to side RT, what would be its potential energy if it reaches at S, of which S is the midpoint? Now, the secret you need to know here is that the potential energy and the kinetic energy of the object is always, is the same. Okay. So here, if we have 72 joules of energy, if we have 72 joules of potential energy, mean that the kinetic energy here will be 0 because it's not moving. Okay. Kinetic energy will be 0. Now, as it begins to fall, it starts gaining kinetic energy and losing potential energy. So by the time it reaches halfway, the potential energy will be equal to kinetic energy, of which they are going to divide this. We have to divide this total potential energy into 2, because it is gaining kinetic energy and losing potential energy as it is going down. So when it reaches the midpoint of each fall, it will be potential energy is equals to kinetic energy, of which we need to divide the total potential energy divided by 2 for us to find its potential energy at S. So what we're going to do is the potential energy at S would be 1 over 2 times 72, or just divide 72 by 2, okay? Then you say potential energy is equals to 2 into 7, goes 3 times, remainder 1, then there 6. So the potential energy at S will be 36 joules. The potential energy at S will be 36 joules. Quickly we move on to question 6. Calculate the height TR. Calculate the height TR. Okay, so to find the height TR, now this is where we need to use the formula for potential energy, because on the formula for potential energy there is this H which represents the height. So this is our C Roman numeral 1. Okay, so potential energy, we know that it is 72 joules. So we place where potential energy, we put 72 joules, which is equals to mass. We have been told that this stone has 2 kg, so 2 times gravity is always 10, then times the height, the one we want. So this becomes 72 joules. 72 joules of energy is equals to 2 times 10, that is 20 times h, which gives us 20 h. So to find the height, we're going to divide 72 by 20. So here, divide by 20, even here by 20, for us to remain with h. 20 into 20h, h is equals to 20 into 72. So 72 divided by 20, we have 3.6 meters. So the height TR is equals to 3.6 meters. So therefore TR is equals to 3.6 meters. Okay, we go to question C Roman numeral 2. Calculate the velocity of the stone just before it strikes the ground. Calculate the velocity of the stone just before it strikes the ground. So to find the velocity, we have to use the formula for kinetic energy. We need to use the formula for kinetic energy. So kinetic energy is equals to 1 over 2 mass times the velocity squared. Now remember I said the potential energy and kinetic energy is always the same. So if we have 72 joules of potential energy, even if when immediately before striking the ground there, the total kinetic energy will be 100%, which is 72 joules, and the potential energy will be 0 just before striking the ground. Remember I said it is gaining kinetic energy and losing potential energy. Okay, so the kinetic energy is 72, which is equals to 1 over 2 times the mass of the stone, which is 2 times the velocity squared, the one we want. Okay, so we have 72 is equals to 2 there, 1, 2 there, 1. So we have 1 times v, we have v squared, which is the same as v squared is equals to 72. So to find this, you need to remove the 2 by introducing the square root. Okay, so the square root and the square cancels, v is equals to, you find the square root of 72. So the square root of 72 is equals to 8.48. So velocity is equals to 8.485 meters per second. Velocity is equals to 8.49. Around the digit there, okay, now we can leave it in any decimal place, it's not specific in this case. So 8.49 meters per second. Okay, so this is how we deal with these kind of questions in physics. It's very easy. Please do not forget to subscribe leave comment in the comment section below. I'll be replying to your queries. Thank you and have a good day. Bye bye.